Hello, and welcome to this short video on batch job scheduling. I'm going to describe the basic features and benefits of using a job scheduler, and I'll use a commercial package from Open Systems Management Limited called Cosbatch to illustrate how such packages work in practice. Job schedulers, sometimes called batch job schedulers, handle the otherwise unattended background execution of processes that need to be run on one or more computer systems. Foreground jobs, that is, jobs with which you interact via a real-time user interface, are those most often encountered by end users. But most commercial, government and other larger organisations also run a lot of jobs that demand background processing. For example, let's look at a payroll application on the basis that we're all familiar with being underpaid for what we do. An organisation might generate timesheets for its employees in real time as a foreground or interactive process, but at the end of the payment period, those timesheets may need to be processed in batch mode. They may need to be computed against tax tables and hourly rates to generate the salaries owing, and the resultant data may need to be processed to generate and print payslips, money transfers and reports. All these processes will be run in the background by programs without further human interaction. What may not be immediately obvious, though, is that each of these processes may be dependent on the successful or unsuccessful outcome of a prior job or jobs. There's no point, for example, in generating the wire transfer information to the bank until we've worked out how much we have to pay each of our staff members. A job scheduler is computer software that will manage and monitor these batch jobs and initiate batch job processes only on the successful conclusion of a previous job or jobs. In this case, for instance, execute the wire transfer program only when the compute salaries program has run successfully. This is normally called a dependency. In other words, the wire transfer process is dependent on the outcome of the compute salaries process. It's also sometimes called a precondition, i.e., the compute salaries process finishing successfully is a precondition of the wire transfer process starting. Programs typically generate an exit code or application pattern when they finish, and these can therefore be read by the job scheduler, which will then automatically start the dependent program or programs. In fact, if we look at our flowchart, we can see that there are a number of dependencies whereby the previous job has to finish successfully before the next can start. We might also want to run an alerting program or some other form of error control if a program fails. Maybe this program will send an email or text to the administrator. Today's job schedulers typically provide a graphical user interface and a single point of control for the definition and monitoring of these background executions in a distributed network of computers. In our scenario, the salaries might be computed on one computer system, but the wire transfers might be executed on another, and the reports generated on a third, for instance. So let's look at how a job scheduler works in practice. This screen is from Cosbatch and illustrates the same set of jobs that we just went through for payroll processing. One of the benefits of a modern-day job scheduler is that you can organise your background jobs into suites, whereby all the component jobs are managed and monitored as a single object. In this example, it's called the payroll suite. We've defined the exit codes and patterns that we need to recognise for each dependent job to execute. A job returning an exit code of 0 has normally finished successfully. So here, I've defined that my wire transfer job will run if the compute salaries job has ended with an exit code of 0. I've also configured my error program to run if the compute salaries job ends in the string error. I've built in the dependencies for all other jobs in the suite. Now my job suite will run automatically in the background under the control of the job scheduler, which will kick off each new job as the one on which it depends finishes. Of course, you can also make a job run on the successful or unsuccessful outcome of multiple jobs, or initiate multiple jobs on the successful outcome of a single job. So that's fine as far as it goes, but now we want to add scheduling. Having automated the sequence, I want to run it automatically in the background every payday. The best schedulers have a very granular capability for scheduling when jobs or suites of jobs should run. For example, Cosbatch allows you to schedule specific dates and times, frequencies, for example, run those jobs every 2 hours, and calendars for when jobs and suites should run. These may be used in any combination. You may, for instance, want to run the payroll every Friday at 10 AM, unless the Friday is a public holiday, in which case you want to run it on the prior working day. So now we know we can automatically run the payroll suite or any other job or suite according to whatever combination of dates and times we can come up with. But sometimes even that's not enough. Let's look at our example again. The tax data and hourly rates are not going to change that much on a week-by-week basis, but the timesheets change every week. And I can't run my payroll without the new timesheets being present, no matter what date and time I say that the payroll suite should run. Again, the better job schedulers have an answer for this by using what is called event-driven scheduling. In this case, the event is the existence of the timesheet file. Unless the scheduler finds that the timesheet file is there at the appointed date and time, it will not initiate the payroll suite. Most operating system platforms such as Unix, Linux and Windows provide basic job scheduling capabilities, for example, the cron utility. Many major applications and infrastructure programs such as databases, accounting software suites, etc. also include relevant job scheduling capabilities. These tend to be limited, either in function or in generic applicability, and most mid to large scale organisations will use a commercial third-party job scheduler. The better schedulers, such as Cosbatch, all provide automatic failover, audit trails for compliance, network awareness, support for heterogeneous platforms, and real-time monitoring, among other features. Hopefully, this gives you a brief understanding of what job scheduling software can do for your organisation. If you've got any feedback on this video, we'd love to hear from you. You can email us at info@osninc.com. Thanks for your time.